Welcome to the last video for Unit 1 on measures of dispersion. Our objective is to solve problems involving the measures of dispersion, which are range, interquartile range, and standard deviation. Okay, so some definitions on the measures of dispersion. Range is the highest value minus the lowest value of a data set. Interquartile range, it's the difference between the third and first quartile. Variance is a little complicated. The variance of a data set is the average distance the square of each data value is from the mean. You don't really need to know what variance is, but we use variance to find standard deviation because the standard deviation is just the square root of the variance. And so what the standard deviation ends up telling us is how far from the mean a data value is with respect to how far the other data values are from the mean. Now I'm going to talk to you about how to find the standard deviation of a data set. To find the standard deviation by hand, the first thing we need to do is find the mean of the data, then subtract the mean from each data value, then square the differences, then find the mean average of the squares, and this right here, this step, this is the variance. But when we take the square root of the variance, we get standard deviation. These 5 steps are not something that I expect you to do every time, but I need to show you where standard deviation comes from. After this, we're going to be using our calculator to calculate the standard deviation. So, we have a small set of data, 10, 15, 25, and 30. I wanted to do a small set of data because really finding the standard deviation by hand is not fun. You can tell that I don't really like doing this. It's just a lot of steps. Our first step is to find the mean of the data. So to find the mean, x bar, I'm going to do 10 plus 15 plus 25 plus 30. And there's 4 pieces of data, so divide that by 4. 10 plus 15 is 25, plus another 25 is 50, plus 30 is 80. So 80 divided by 4, which is 20. So the mean of the data is 20. The next step that I have to do is subtract the mean from each data value. So 10 minus 20 is negative 10. 15 minus 20 is negative 5. 25 minus 20 is 5. And then 30 minus 20 is 10. So in this step finds the distance each data value is from the mean. So 10 is negative 10 away from 20, and 15 is negative 5 away from 20, and 25 is 5 away from 20, and 30 is 10 away from 20. The next step is to square those differences. So I have negative 10 squared, I get 100. I have negative 5 squared, I get 25. I get 5 squared, I get 25 again, and then I get 10 squared, and I get 100 again. So this step exaggerates those distances the data values are from the mean. The next step is to find the mean average of the squares. So I'm going to take these square values, add them together, and find their mean. So 100 plus 25 is 125, plus another 125 is 250. Divide that by 4, and I get 62.5. And this number right here, like I said in the last slide, is the variance. But my goal is to find the standard deviation, right? So the last step is to take the square root of that variance, the square root of 62.5. The square root of 62.5 is 7.91. In this class, we're going to always do to 3 sig figs if we have to round. So 7.91 is the standard deviation. And remember, it tells you how far from the mean a data value is with respect to how far the other data values are from the mean. Basically, like I said just now, it tells you how varied the data is. So the smaller the standard deviation is, the more clumped together the data is. The larger the standard deviation is, the more spread out the data is. Okay, so calculating standard deviation on the calculator. So we're going to do the same set of numbers, and let me pull up my nifty calculator. Okay, so to find the standard deviation using your calculator, you're going to press Stat on your calculator, Edit, and you're going to enter the set of data into your list. So I'm going to enter 10, 15, 25, and 30 into L1. Then you're going to do Stat, Calc, 1var stats. That's becoming your very good friend. Because I entered everything in L1, I don't need to put anything next to 1var stats. I can just press Enter, and right here, this one right here, this is lowercase sigma, is the standard deviation. And so that's the same thing that we got by hand. In this class, we used the lowercase sigma for our standard deviation, 7.91. Okay, so what if you have a set of data that's already put together in a frequency table? So this data right here is in a frequency table. It basically says that there is a frequency of 1 of the number 3's, and there's a frequency of 3 for the number 7's, and there's a frequency of 2 for the number 12's, etc. So you're going to do the same thing. You're going to go to Stat on your calculator, Edit, and you're going to enter all your classes in L1 and your frequencies in L2. Okay, so I'll enter the classes in L1 and the frequencies in L2, and you'll just go to Stat, over to Calc, 1var stats, and you're going to do L1, second L1, comma, second L2. It's going to multiply those two columns together, and we're going to look at this lowercase sigma for our standard deviation. So the standard deviation is 5.04 to 3 significant figures. So just remember, the larger the standard deviation, the more the data is spread from the mean or spread out, and the smaller the standard deviation, the more the data is grouped about the mean or clumped together. Okay, so the last thing I want to talk about is the difference between these two symbols. So you notice on the calculator, one of them, or you might have noticed on the calculator, that the number I wanted you to pay attention to was this sigma. It had sigma x, but right above it is an S of x. And this right here, S of x, is actually the sample standard deviation of the data set, and this right here, the sigma, is the population standard deviation. And so in this class, we are always going to look at the population standard deviation. We're not going to look at the sample standard deviation. So always, if you use your calculator, look at the sigma standard deviation. If you get into some statistics classes in college, you might do it the other way around when you're only looking at the sample standard deviation. And that's actually normal practice, because very rarely do we have all of the data for an entire population. We usually have a sample, but in this class, in this IB class, we're going to only look at the population standard deviation. Okay, so I think that is about it. Good luck on the practice problems, and I will see you later.